Dear students, I welcome you to my video lectures. I'm your course instructor, Dr. Mazullah Khan. In today's lecture, I will talk about parts of chapter number 15, which is required return and the cost of capital. If you remember from my previous lectures, we started with evaluating cost of debt. Then we moved on and calculated cost of preferred stock. And then we used different techniques, for example, dividend discount model and some other methods, and calculated cost of equity. In one of my lectures, then we used these three components and calculated the weighted average cost of capital. And the reason we call it weighted average cost of capital, because each component of this investor supplied capital, it was weighted, and then we calculated a weighted average of all the costs. That's why it's called weighted average cost of capital. But of course, there are some limitations of WACC. One of the limitations was marginal capital costs. In my second lecture, I talked about the limitation of WACC in detail. One of the limitations was that whenever we disturb the capital structure of a company, of course, the financial risk of that company also changes. So it's not a good idea to use the same WACC, let's say if we are considering a new project. Then the other limitation was flotation cost, and of course, we covered the flotation cost in my third lecture, and we adjusted for flotation cost in two different ways. One, we adjusted the initial cash outlay, and the other method was that we actually adjusted the discount rate. So whenever a company is considering a certain project, okay, sometimes it's not a good idea to use company's WACC to evaluate that project. And the reason is very simple, because if a company is considering, let's say company is Engro, okay, so Engro is in different lines of businesses. For example, they are in fertilizer, they're also in chemicals, and they are also doing a very good business in food. Okay, so for example, at one point in time, Engro was considering to introduce, let's say, a different line of business, which is in food. So the question that the Engro management might have faced, which WACC should they use for evaluating this project? Should they use company WACC, or should they use a different WACC? Use a company's WACC is not a good idea. The reason is food business altogether, it has different dynamics. So the risk associated with this new line of business is entirely different than other lines of businesses for the company. So the whole point of this discussion is that sometimes it's not a good idea to use company's WACC. You have to use a project specific WACC, weighted average capital, cost of capital. If we are using project specific required rates, we use CAPM approach. So if you remember, CAPM approach is the return, let's say, of a stock, RJ, is the risk-free rate, and of course the excess return over the market. So let's say if the market return is RM, and I put it R bar underscore M. M is for market, and this bar is actually the average return for the market. And once I subtract the RF, this part is actually the excess return. Okay. And of course, the way this particular stock responds to the market, that responsiveness is captured by beta. It's the systematic risk. Systematic risk. Okay, so whenever the market moves, the return on that particular stock also changes. Okay. So whenever we are using CAPM, which is the capital asset pricing model approach for project specific returns, we have to follow certain steps. The first step is initially we have to assume that we are financing the new project with equity alone. So the new project will be all equity. Okay, so this is one of the starting point. So this is like a big assumption, though we will make some adjustment afterwards, but the initial start is that we assume that the new project, so for example, if Ingro is considering to go into food business, the first assumption is, okay, what if we finance the whole project with our own equity? So no debt financing. Okay. The second part is determine project beta. How do you do that? I will tell you in the coming few slides. And then we have to calculate, of course, the expected return. So once we get hold of beta, we can calculate expected return. And as I said, the assumption here initially was that all the financing is coming from equity. Practically, most of the time it's not like that. Part of the equity is coming from debt, and part of it is coming. I mean, part of capital is coming from debt, and part of the capital is coming from equity. So let me write it down for you. So the capital that we need for a project, part of it is coming through debt instrument, so which can be bond or bank loan or anything else, and part of it can be through equity, okay, through stocks. So this is like a very, very real situation, okay, and the reason companies do consider a mix of financing like debt and equity, the reason is every company, they have an optimal capital structure. So the management thinks that, okay, for example, our optimal capital structure is, let's say, debt 40%, equity is 60%. So let's say if there is all the capital to equity, it disturbs this optimal ratio. So normally, for bigger projects, companies consider a mix of financing. Yes, investments are lumpy, as I said in one of my lectures, but in longer term, actually, they try to balance this ratio. So if the company is considering a mix of debt and equity, of course, we have to make some adjustment. Okay, so the whole point, we started with the assumption that it is all equity, but in reality, it's not. So we have to make an adjustment. Okay, and then the final step is actually for decision making. So you have to compare cost to the IRR of the project. Okay, so cost versus IRR, internal rate of return for the project. So let's say if the internal rate of return for the project is more than the cost, of course you accept that project. But let's say if it's otherwise, if its IRR is less than the cost, we reject that project. Now, there are few difficulties in determining the expected return. And the reason is, so let's say if Engro is going into food business, of course they do not have a project specific beta. So unless and until you have something in reality, this is something which is not existing. This is something for the future. So how do you calculate beta for it? But of course there are some solutions. One of the solution is locate a proxy. Okay, from location of a proxy or identification of a proxy, what it really means that Engro should look for those companies who are engaged in food business, who are already engaged in food business. Okay, so there are many companies in Pakistan who are already doing business in food or beverages or any specific product line. So yes, project betas, we do not have betas for specific projects because the project is for the future. We do not have any historical data on that. So what Engro in this situation can do, they can identify a certain company or maybe a set of companies who are already in this business. Okay, they are called proxies. Okay, so the assumption is whatever is the beta for those other companies, our project will have a similar beta. Of course, they also do some adjustment in practice, like in industry. Once you start evaluating different projects, they make a little bit of tweaking. They fine tune the beta, but the starting point is you have to identify similar companies. That's why it's called proxy. Okay. The second step is, of course, plot the characteristics line relationship between the market portfolio and the proxy asset excess return, and then estimate beta and create the security market line, SML. Okay, I'll show you on the next slide. Okay, but before showing you the graph, of course, where do you get these proxies from? Now, this is a very, very interesting question. Where are we getting these proxies from? In Pakistan, of course, you have to do your own research of the market. And Pakistan's market is not that huge, so it's in a way not that difficult, but of course, the difficult part sometimes is that you do not have comparable companies, okay, which has an established history. In North America, 3 countries, Canada, Mexico, and United States, they are following North American industry classification system. It's pronounced as NACS. Okay, so all the industries are actually, they have a specific classification code. So for example, if you are evaluating a project in, let's say, in Canada or in the United States, and you can easily find that classification code, and just with a single press of a button, you have lots of companies actually appearing on your screen that, okay, these are the comparable companies. Okay, these are the companies which are operating under this code, which means similar companies. Okay, it's a 5 or 6 digit code. The next step is choose similar companies, rank them based on their beta, and then take a median or mode. Average is not recommended. So suppose you finally chose 5 different companies, and let's say the betas for company number 1 is, let's say, 1.2, this one is 1.25, so 1.20, this one is 1.25, okay, this one is, let's say, 1.37, and this one is, let's say, 2.49, and I'm taking this extreme value for a reason. I'll explain you the reason why. Okay, so the book actually recommends that we should take the median value, and of course the way you identify median is, of course, rank the data first. So for example, let's say from low to high, okay, and then you can identify the median. Mode is also acceptable, but the most recommended one is median. They do not encourage actually average, although this one is also a measure of central tendency. But the reason they do not encourage or recommend, let's say, average, the reason is average is sensitive to extreme values. So average actually moves to extreme values. Okay, so that's why the evaluation methods do not recommend to average out betas. Okay, they recommend median. So yes, we can easily identify some companies where we can use their betas as a proxy for our project. Okay, now this is security market line. Okay, security market line is a line, it's a linear relationship, actually linear relationship, and you can easily identify estimate this line through regression. So it's like an econometrics technique. It's a very popular technique. So let's say if you are doing research, if you are thinking of becoming a researcher, these are the essential tools. But of course, this is not part of your course now, so I wouldn't talk about those techniques right now. So it's a linear line, okay, and it tells you a relationship between systematic risk, which is like captured by beta in CAPM, okay. So this is like that beta, okay, and this is the expected return. So beta tells you the systematic risk of that particular company, and of course, if the risk is more and more, with increased risk, you need a more expected return to compensate for that risk. So as we say, higher the risk, you need a higher return to compensate for that risk, okay. So let's say if risk is here and this is, let's say, your expected return, but let's say if you increase the risk by some margin, let's say, right, this is actually, sorry, so this is your expected return. So whenever you increase the risk, of course your expected return also increases. Now if your project return is above this security market line, that's an acceptance region. So the whole region above this blue line, it's an acceptance region, okay. So why is it an acceptance region? So for example, for this risk, I need a minimum of this much return. But let's say if the return is somewhere over here, of course this one is more return than my minimum requirement, okay. So I accept that. But what if for a similar risk, if my let's say project return is here, of course this is not optimal, because according to this security market line, this is my minimum rate of return that I'm expecting, okay. So anything below, I do not accept it, okay. This is the risk-free rate. The reason this is the risk-free rate, because here beta is equal to 0. So it's a risk-free security. When beta is 0, this is a risk-free security, a risk-free security, okay. And then the minimum return is, of course, whatever the risk-free security pays. Like for example, government bonds, okay. Like for example, in Pakistan, it's Pakistan investment bond. The beta is 0 because there is no risk, okay. So the return associated with it, it's called the risk-free return, okay. So that is the minimum return that you need from an investment, from any kind of investment, okay. So we make actually a small adjustment in CAPM, and then we can, what do we do? Calculate the required return for project K. So suppose the project is labeled as K. It's a particular project, for example, food business or anything else, okay. Assumption again, it's all equity financed, okay. So RK equal to RF, which is the risk-free return, plus this is the excess return over the market, okay. So excess return, okay, and this is beta, okay. Adjust for capital structure. Now in the second step, what we do, if you use all equity beta, of course it wouldn't reflect the true return of the project. You have to adjust for weights of different financing options. So for example, if you think that, okay, I would use a certain portion of a debt and certain portion of equity to finance that particular project, you use those weights. So for example, 40% is debt here, and then 60% remaining is equity. So you multiply KI, which is the cost of debt, with RK, which is cost of equity, and then you get weighted average rate of return. So these concepts are not that difficult. They are very easy. Of course, you start with a simple assumption. You think that, okay, I assume that I will use only equity financing, and then you do adjustment. Just to give you a simple example, assume a computer networking project is being considered with an IRR of 19%. Examination of firms in the networking industry allows us to estimate non-equity beta of 1.5. Our firm is financed with 70% equity, okay? So this is the capital structure of this company, okay? And 30% debt at KI equal to 6%. The expected return on the market is 11.2 and the risk-free rate is 4%. So I have all the parameters actually to calculate my project-specific required rate of return. Now, here the project is actually in the networking industry, okay? The book actually has a very, very good example that why do we need a project-specific proxies. Reason, suppose there is a company which is mainly engaged in, let's say, producing some chemical products, okay? That company is considering to undertake a project which is what they call real estate. So for example, they are considering to make some buildings, okay? They're considering to undertake a project which involves some construction, okay? Now, for this project, of course, it's not a good idea to use WACC for chemical industry, okay? Because the project is in the real estate. So a good idea would be to use a beta from the industry for those companies which are already engaged in the real estate. It means that the companies that we are using, their betas, they're called proxies. Okay, so we proxy our beta with their beta. Okay, so in this particular example, if the company is considering to undertake a networking project, of course they have to consider the beta from networking industry. Okay, so I have all the parameters, and it's once I plug all the numbers in, my weighted average cost of capital is 12.16. So RF is 4%, 11.2% is the market return, and once I subtract the RF, which is the risk-free rate, it's the excess return, okay? And once I multiply it with 1.5, the cost of equity is 14.8, okay? The weighted average cost of capital, so since 30% is coming from debt, and this 70% is coming from equity, so we multiply these rates by its weights. So the weights are 30% debt and 70% equity, so WACC is 12.16. Now decision, do you accept this project or do you reject it? Of course, the IRR that we calculated, the IRR of the project is 19%, okay? This is given. Okay, how do we calculate, how do we find out the IRR? We already calculated it in chapter number 13. Okay, so we discount the cash flows and find out the rate at which your NPV is 0. So this is the rate at which NPV equal to 0. Okay, and now this is something that we calculated right now. Okay, in chapter number 13, if you remember, the acceptance criteria for a certain project was, compare IRR with cutoff, or what they called hurdle rate. Okay, so if the IRR was more than the hurdle rate, okay, conclusion was accepted because the return is more than the cutoff. Okay, now I'm sure once I was teaching chapter number 13, the first thing which might have come to your mind, how do we set up actually the hurdle rate for a project? So this is actually the hurdle rate. Okay, so this is the way we calculate hurdle rate for a company, and of course for each project we have IRRs, and we calculate IRRs based on discounted cash flow model. So if the IRR is 19%, of course the return is more than the cost. So this one is cost. weighted average cost of capital. Okay, so this first C is cost. Okay, weighted average cost of capital. Okay, so since the return is more than the cost, we accept this project. Okay, now we considered a project specific required rate of return, but sometimes we specify group specific required rate of return, and the process of using CAPM for project selection in case of group specific. So one was project specific, okay, project specific. Okay, the other one is group specific. Okay, and why do we need group specific rates of return? The reason is it's very easy to implement. Okay, calculating hurdle rates for project specifics for different projects, it's very tedious. Okay, so what we do in this approach, a company is actually divided into different groups. For example, good example, Engro. Okay, so Engro has, as I said, fertilizer. Okay, they have chemicals, and they have food as well. Okay, so for each line of business, for each division, as you can say, division of operation or division of product, right? So you create those divisions based on something, right? So each division or each category actually is a group. So you identify, you calculate actually a group specific required rate of return, and you follow exactly the same approach. Okay, you initially assume all equity financing, then you determine group beta, and then you calculated the expected return adjusted for the capital structure. Okay, why do we do that adjustment? Because the assumption was initially all equity, but in reality we use different proportions of debt and equity. Okay, and then you compare cost to IRR. So do not get confused. The first thing I talked about was project specific. Now I'm talking about group specific. Okay, for group specific, I'm copying this image from the book. Okay, so again, this is the systematic risk, which is beta for the group, and this is the expected return. So some of the groups may be like super safe. So this is like safe, okay, and this one is more risky. Why is it more risky? Because if you see here, the systematic risk is way higher, and let's say here the systematic risk was around here. Okay, so the systematic risk is more, and of course to compensate for that risk you need a higher return, which is here. Okay, so here in normal circumstances anything above this line would be acceptable, although for overall company, like for example for Engro as a company, okay, this is the acceptance line. So this is the cost of capital for a company, right? But if we divide cost of capital group wise, like for food and for chemicals, and let's say for fertilizer, okay, one line of business is more risky than the other, and similarly the risk associated with it and the expected return associated with it, they are different. So for example, a return for a certain group may be acceptable, like for example this one here is acceptable, okay, but if you compare this required return with the company's cost of capital, of course then you reject that project because it is less than the cost of, the return is less than the cost. Okay, so you will reject that. But if you're let's say if you're considering all projects in a segregated way and you compare the internal rate of return of that project with the group specific cost, then of course you accept that. Okay, so the best part about this approach is, of course, sometimes you consider those projects which may otherwise be rejected, and you benefit, I mean your company overall benefits from that. Okay, so it gives you a more segregated approach but a more accurate approach, put it that way. Okay, even then we tried, we found out some remedy, let's say for what we call the marginal capital. Okay, so that was one of the limitation. We did project specific evaluation, and then we did actually group wise. Okay, but even then it has some limitations. So for example, one of the limitation is amount of non-equity financing relative to the proxy firm. So let's say if I'm using any company as a proxy. Okay, so again, let's say I am considering to evaluate a project for Engro, food business, okay, or let's say chemical, okay, and I'm using, let's say, ICI, which is another company, and they are heavily engaged in chemicals, okay. If I use ICI's beta, okay, one of my assumption was that assume that it's all equity financing. So whatever beta of ICI is, of course, this beta corresponds to ICI's debt and equity structure. Okay, so let's say if ICI has 30 and 70% ratio, so 30% debt and 70% ratio, how can I use this beta, let's say for Engro, where debt is, let's say 40% and equity is 60%. Okay, so it does not, one of the limitation is it does not take into account the capital structure of the proxy firm. Okay, so of course it needs some adjustment, again further adjustment, but those adjustments are more sophisticated. I wouldn't go into detail, so I'll stop here. Actually, I wouldn't go into further adjustments. The standard problems in the use of CAPM. Okay, and what is the standard problem? Potential insolvency is a total risk problem rather than just systematic risk. So if you remember, total risk is systematic risk, okay, and plus unsystematic risk. Now CAPM approach actually takes into account only the systematic part of it. Okay, what happens about unsystematic risk? Okay, this is something coming from the system, we cannot diversify it, so we call it, this risk cannot be diversified, risk can't be diversified. Okay, but what about this risk? This is something that you can diversify through different techniques. Okay, and of course this is beyond the scope of this course. I wouldn't talk into those techniques, but total risk is a combination of your systematic risk and unsystematic. Unsystematic risk is actually company specific, and it is not market specific. It may be industry specific, but most precisely it's company specific. To a lesser extent it is industry specific, but of course it is not market specific, because market is something which is related to systematic risk. Okay, so total risk is systematic risk plus unsystematic risk, and CAPM approach unfortunately takes into account only the systematic risk. Okay, there is no way we can take into account the unsystematic risk. Okay, because we cannot predict any company specific, for example, let's say anything like one of the major, let's say, unsystematic risk, let's say for example for airline companies, let's say the prices of oil, right? That is systematic risk. I mean, you cannot do anything about that. You cannot do anything about that. Or like for example the pandemic, okay, the COVID-19 pandemic, right? A company cannot do anything about that. Okay, it's a systematic risk. Okay, that risk cannot be diversified. But of course, something like, for example, oil pricing, you can hedge actually, right? So you can buy futures. Okay, and you can okay, this is beyond the scope of this course. I wouldn't talk about this topic anymore. So one of the problem of CAPM is, unfortunately, it takes into account only systematic risk and it does not consider unsystematic risk in its, in the model. Okay, I will stop here, and in my next lecture we will talk about total risk. Okay, so I'll stop here. If you have any questions, you're more than welcome to ask me these questions on my WhatsApp group or through my email. I wish you all the best and have a wonderful day.